Another method of solving quadratic equations is completing the square. To solve ax squared plus bx plus c equals to 0, where our leading coefficient a is not equal to 0, using completing the square, there are 5 steps. Whenever your leading coefficient is not 1, meaning that you have some number times x squared. If you have x squared as the first term, then you can skip this step. Step number 2, you rewrite the equation so that your constant term is alone on one side of the equation of the equality symbol, meaning that you have your number by itself on the right side of your equation. Then you square half of the coefficient of x and add this square to each side of the equation. Well, I'm going to go over the steps. Then step number 4, you factor the resulting trinomial as a perfect square and combine the like terms on the other side. Then you use the square root property to complete the solution. Here's our first example applying the completing the square method. X squared minus 4x minus 14. I first need to, as my first step, if my a is not equal to 1. In this case, after I identify my a, which is the coefficient of x squared, is 1, I don't have to do the first step. I can skip the first step. My b is going to be negative 4, and my c is going to be negative 14. Those are my a, b, and c for this equation. Because my a is 1, I skip step number 1. Now I rewrite the equation so that the constant term is on the right side. I'm going to move this negative 14 to the right side of my equation by adding 14 on both sides. Plus 14, plus 14. This is my second step. Now I have x squared minus 4x equals 14. Now I'm going to square half of the coefficient of x. My coefficient for x is my b value, negative 4. I'm going to square half of it. Negative 4, or half of negative 4 is negative 4 divided by 2 squared. That is negative 2 squared. And when you square a negative number, it becomes a positive. So the value that I will be adding to both sides is positive 4. Let's do it. I'll have now plus 4, plus 4. Let me do it in blue so you can see the steps. This is my third step. I'm going to add 2 on both sides. X squared minus 4x plus 2, plus 4, plus 4 equals 14 plus 4, which is 18. And now I'm going to factor my left side, step number 4. Factor the trinomial on the left side as a perfect square. This will be my x squared. This is 2 squared. And the middle number, it's negative 2 times 2 times 1, which are my coefficients. Oh, sorry, times 2 times x. And this is my x, this is my y. If you have issues factoring as a perfect square, please go back to the factoring polynomials chapter and review the actual steps on how to factor a perfect square trinomial. But now this part right here, it's factored out as x minus 2 squared equals 18. Then we apply the square root property. This was my fourth step. Yes, this was my fourth step. And my fifth step is to apply the the square root property that we just learned. The square root property is the one that says x squared equals k, then x is equal to positive and negative square root of k. So this is my x in this case. I will have x minus 2 equals positive and negative square root of 18. From this point on, it's just simplifying and moving that negative 2 to the other side. I'm going to keep on going on a different slide. Let me delete this part. I'm going to continue where I left off. I'm going to add 2 on both sides so I can have my x by itself. Now I'll have x is equal to positive and negative square root of 18 plus 2. Because I have a radical, I have to check if I can simplify it. Remember, you rewrite your 18 as a radical of the factors of 18, which I'm looking for a perfect square. I'm going to choose 9 and 2. 9 and 2, that's the square root of 9 times the square root of 2. The square root of 9 is 3. So the square root of 18 can be simplified as the 3 times the square root of 2. My solution set, after I change this 3 square root of 2, after I replace the square root of 18 by 3 square root of 2, my solution set is 3 square root of 2 plus 2 and negative 3 square root of 2 plus 2. In the solution set form, you can say, I'm going to flip it around so I can use the plus or minus notation. 2 plus or minus 3 square root of 2. That's my possible solution set in both set notation and just as an answer.